Let's talk about some cautionary tales. There's an interesting article here about ways that machine learning or AI has gone wrong. I want to highlight this one where some doctors set up an AI that could help them use chest rays to predict which patients were at high risk of pneumonia. The system made accurate predictions from X-rays shot at one hospital, but totally flopped when they tried it on images taken at other hospitals. Eventually, the researchers realized that the computer had learned to tell the difference between that hospital's portable chest x-rays taken at the patient's bedside versus those taken in the radiology department where you have to like wheel the patient down there, for example. Doctors tend to use portable chest x-rays for patients who are too sick to leave their room, so it's not surprising that those patients had a greater risk of pneumonia or lung infection. There's the study title. And I looked it up, and the portable x-rays had a 34% prevalence of pneumonia or lung infection, while the non-portable ones, where you have to wheel the patient down to the radiology department, had only a 1.2% prevalence. And they dug into it, and the AI had learned to look at on the image, there was like a marker of this is the left side of the patient's body, this is the right side of the patient's body. And that was done differently for the portable machine versus the non-portable, and the AI clued in on that. And it turned out there were other ways that the AI was looking at it and could tell the difference between portable and non-portable, many of them not visible to humans. Um, Another famous story in the 1960s, the US Army or some company working for the Army tried a neural network to detect tanks in pictures. They took 100 pictures of a forest with a tank visible and another 100 for 100 photos without the tank. They might have even tried different kinds of tanks. I can't remember. They split the data into a training batch and a test batch, like split this 100 into 50 for training, 50 for test, split this 100 into 50 training, 50 for test. They trained an algorithm and tested it, and it was pretty good at saying whether there was a tank or not. And here's the citation for it. Now, here's the part that might be more legend than true. Then, after they trained this algorithm and tested it on their test images, they went out into the real world and tried it again, and it was terrible. They eventually figured out what was wrong. The 100 pictures with a tank that they had taken were taken on a cloudy day, and the 100 pictures without a tank were taken on a sunny day. And the algorithm had learned to tell the difference between a cloudy day and a sunny day and had no idea about tanks. And not that algorithm has an idea anyway. But there's a word I introduced earlier this semester that describes this issue. Can you remember what that word is? It's confounding. The cloudy versus sunny weather was completely confounded with whether the image had a tank or not a tank. So we got to think ahead to how we're going to collect these images. There's some doubt as to whether the cloudy versus sunny thing actually happened. You can read more about it there, but it's a good lesson. So what should you do instead? Or let's say you're trying to build an AI to detect deer that are maybe in the roadway or going to jump into the roadway, pose a danger to people that are or cars that are driving. Think about how you would design a photo collection task. Pause the video while you do that. Okay, welcome back from pausing. So I'd say take a photo of a scene with no deer, a bunch of photos. Then pose a fake deer in the scene, take another photo, try different poses like the deer is head on, left side, right side, rear end of the deer, half turned, neck of the deer turned versus not turned. Is the deer in the center of the frame, halfway to the side, halfway off the side of the frame, deer on the road, deer and the next to the road. Is it a 2-lane road? Is it a 4-lane road? Does the picture have lots of foreground and not much sky, or not much foreground and a lot of sky? Try different zoom amounts, repeat it for different scenes and different deer, like antlers or not, baby deer or not. Do you have 2 deer in the photo, 3 deer in the photo, etc.? Do it all again on a day with different weather conditions. Do it all again on another day with even different weather conditions. Do it all again with another kind of brand of camera if you want your AI to work in different car makes and models, or even next year's version of this make and model might have a different camera. And then just keep thinking about all that variety. Does this sound repetitive? Yes, that's the point I'm trying to make, that we got to plan ahead and try to collect as wide of a data set as possible. So how can we get labeled data to train on? Maybe we'll make that the next video.